Hello, fantastic learners! Welcome to our follow-up video where we reveal the detailed solutions to those brain-teasing questions from our last lesson on changes in energy stores. Get your notepads ready, because we're diving straight into each scenario. A roller coaster car is pulled to the top of a big hill. Then it rushes down and eventually levels off at the bottom. Going up the hill. As the coaster climbs, a motor does work against gravity, transferring electrical energy from the power system into gravitational potential energy of the car. Kinetic energy is relatively low here because the car is moving slowly. At the top, the coaster has maximum gravitational potential energy because it's at its highest point. Kinetic energy is still moderate if it's moving, but not as high as later on. Rushing down. Gravitational potential energy decreases rapidly as it's converted into kinetic energy, making the coaster speed up. Some energy is transferred to the surroundings as heat, due to friction on the tracks and wheels, and perhaps a little sound, the roar of the coaster. Leveling off. Near the bottom, the coaster has maximum kinetic energy. Over time, friction and air resistance continue to transfer energy away as heat and sound, which eventually slows the coaster. Energy transitions from gravitational store to kinetic store, plus some loss to heat and sound in the surroundings. A solar-powered toy has a small fan that spins on a sunny day. Sun's energy. The sun provides light energy, and some thermal, which arrives at the solar panel. Conversion in solar panel. The solar panel converts light energy from the sun into electrical energy. Motor and movement. That electrical energy powers the small motor, turning it into kinetic energy for the spinning fan blades. Other transfers. A little energy goes as heat in the motor and a faint whirring sound from the fan. Light energy is transferred into electrical energy and in turn kinetic energy, with a bit of energy lost to surroundings. You pop some bread into a toaster, switch it on, and get lovely golden toast after about a minute. From the socket. Electrical energy flows from your home's power supply through the toaster's wiring. Heating element. Inside the toaster, the electrical energy is converted into thermal energy by the heating coils, they glow red hot. Toast transformation. This thermal energy then transfers to the bread, causing it to heat up and toast, a chemical change in the bread's surface. Energy to surroundings. Some of the heat also warms up the toaster's metal parts and the air around it. Where do you see at least two energy stores? Start with an electrical store, end up with a thermal store, and the bread's chemical properties change, too. You drop a basketball from waist height, and it bounces back up but not as high. Initial drop. The ball starts with gravitational potential energy while you're holding it. During the fall, this gravitational potential energy is converted into kinetic energy as the ball accelerates downwards. Impact on the floor. When it hits, the kinetic energy is partly converted into elastic potential as the ball squashes. However, some is also transferred to the floor, to sound, and to thermal energy, a tiny bit of heating where it hits. Bounce back. The ball reconverts the elastic potential energy into kinetic energy as it pushes off the ground, but it has less total energy now because some was transferred to heat and sound, hence it doesn't bounce as high as before. Not all the kinetic energy is retained in the bounce, so the ball can't return to its original height. Remember, the magic of energy is in how it changes form but never disappears. Identifying these changes step by step helps you understand everything from toy cars to giant roller coasters. Congratulations on your learning and progress. You've earned this moment to unwind. Recharge your energy by checking out this amazing song next. You're going to love it. Don't forget to like, share, and subscribe if these explanations lit that scientific spark in you. Until next time, keep exploring and keep questioning. See you in our next video. Thanks for watching. Stay curious.